Hello everybody, and welcome to Lesson 2-6, Deductive Reasoning. Alright, let's get it started. Deductive reasoning is the process of drawing conclusions from facts using logical reasoning. And there's a couple ways of doing this. The first of which is the law of detachment. So, given a conditional statement, if the hypothesis is true, then the conclusion is also true. So in the symbolic map, we would say if P then Q, P, therefore Q. And just to be clear, this little symbol that you'll see over here with the three dots that looks like this means, so the three dots means therefore. Therefore. Okay. Right. So it's basically saying in conclusion. So if P then Q, we're saying that P happens, therefore Q will happen. All right, and let's just go ahead and do an example here. So use the law of detachment to give a valid conclusion. If not possible, write no valid conclusion. All right, so let's see how we do. So given, if Mark saves $30, then he can buy a new video game. Mark saves $30. So what do we say? We say if P, then Q. All right, that seems good. And then it says P, therefore Q. So we can conclude Q. So we can conclude that he can buy a new video game. And I'm going to type it so that you can read it. He can buy a new video game. Good for him. Hopefully it's a fun one. All right. And you see how this works. So if P then Q, we know that P exists, therefore Q will also exist. So all we really have to do is rewrite Q. So let's do another one. All right. So if a quadrilateral is a rhombus, then it is also a parallelogram. Quadrilateral ABCD is a rhombus. So Q, if Q, or sorry, whoops, not if Q, what am I talking about? If P, then Q, and then this is P. This is just general quadrilateral. This is telling a specific one. So all we have to do is be a little bit more specific with Q. But this is P. Therefore, the conclusion to Q would be, then it is also a parallelogram. In this case, it is quadrilateral ABCD. So quadrilateral ABCD is a rhombus. A rhombus. Rhombus. Okay. All right. Let's look at another example. Let's look at number 5 at the bottom here. So let's see if this follows the same pattern. If you plan to attend prom, then you must purchase a ticket. Sarah purchases a prom ticket. Now you'll notice here that what this is saying is if P, right? So far, so good, right? Then Q. But is Sarah purchases a prom ticket the same as if you plan to attend prom? No, it's not. So this is actually Q. And what they want to trick you into doing is saying that this makes P true, right? So what they want you to say is, if you plan to attend prom, then you must purchase a ticket. Sarah purchases a prom ticket, therefore she plans to attend prom. That's not necessarily true. I know it sounds like it's logical, but it's strictly not a fact. So this is actually not, this doesn't work, right? Like I said, I know it sounds like it would, but this doesn't follow the pattern, and therefore the logic of it is lacking. And it's also because if you think about it, like, this isn't deductive. This is, okay, well, chances are she's going to want to attend prom, right? But we don't know that for a fact. And we're talking about facts when we talk about deductive reasoning. So this may be an inductive reasoning, but it's not deductive reasoning. All right, so now let's refer to the law of syllogism, which is the second way that we can look at this. So the law of syllogism allows you to draw a conclusion from two conditional statements in which the conclusion of the first statement is the hypothesis of the second statement. So if we look at a map of this, it would be if P, then Q, and then it would be if Q, then R, therefore if P, then R. And this should look very similar to something you already know. There's a thing in math known as the transitive property that says that if A equals B and B equals C, then A equals C. And it's basically the same idea, right? And one thing that is that I think is a good idea is to like think of these as like colors, right? So if you have like red here, right? And then you have the green, we'll just call the B green, right? And then your C, I don't know, we'll make it yellow. Why not? And the idea is that what you're doing is you're using these B's to connect A and C. Because if these parts are true, then you're kind of connecting these. So then your last part would just be the red connected to the yellow. If you want to think of about it like in terms of colors, this may help you out. So let's kind of just do an example. So the directions state, use the law of syllogism to give a valid conclusion. If not possible, write no valid conclusion. All right, so let's give it a shot. If it is Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. So, just like before, what we are doing is we are taking our, let's just do the colors just to make things easier. If it is Saturday, all right, and then the second part is the green, right? Because it's the then Jake has a baseball tournament. And then it says, if Jake has a baseball tournament, and you see how these two kind of connect, then it's going to give the last conclusion that we can actually draw. So in this case, it's the, then he will need to pack his lunch. So remember, the answer is always going to be a combination of the red part and the yellow part. And if you think about this logically, then what they're saying is, if it is Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. So the conclusion is, if it is Saturday, then he will need to pack his lunch. So that's your answer. So if it is Saturday, Jake will need to pack his lunch. All right, and that makes sense. There's our red part of our sentence, there's our yellow, and like I said, it follows the pattern from up here. All right, so let's do number 7. And we're going to do it without the colors this time, because we're just going to try to see if we can look through this and kind of see it now. I just wanted to give you a visual indicator here. So given, if a number is divisible by 12, then it is divisible by 6. And then we're saying, if a number is divisible by 6, it is divisible by 3. So remember that if a number is divisible by 6 is connecting the other two parts. So our conclusion would be, if a number is divisible by 12, then it is divisible by 3. Now this of course is a fact. Anything divisible by 12 is divisible by 3. But this is also the logical conclusion based off of our given statements. Because if a number is divisible by 3, it's divisible by 6. If a number is divisible by 6, it's divisible by 3, which connects these two in a logical way. So if a number is divisible by 12, then it must be divisible by 3 as well. All right, so let's go ahead and go down here to this one. All right, so let's look at number 10. If you shop at Target, then you will use your Target red card. If you do not use your Target red card, then you will not get 5% off. Now, the only conclusion you could probably make, like even if you tried, would be to like negate the first part somehow, but I'm telling you, this is a trap. It doesn't work. So you can't say if you shop at Target, then you will not get 5% off, because like it doesn't even connect. These two statements do not connect these two logically. Because even if this is your green statement up here, like if this part here is your green statement, this part here is definitely not also your green statement, right? So these will not connect. So this is actually not, I'll just choose something a little darker. There is no valid conclusion for this, right? This does not work. So yeah, we'll have to figure out something else in order to get this to work, in order to get our 5%, I guess. All right. Well, yeah, so that is the law of syllogism and the law of detachment. the two logical ways that we can make deductive reasoning. If you are doing well, then go ahead and work on your exit ticket. Otherwise, there's a few more problems here you can try, and I will see you guys next time.